In this video, we will discuss the insertion sort. First, we will see an example of how the insertion sort operates on an array of 5 numbers. We will identify the algorithm used by the insertion sort, and we will see how the insertion sort can be coded in the Java programming language.
We'll start with 5 numbers, 99, 44, 26, 69, and 37. We will think of them as being elements in an array. We will add the array indexes to make this a little easier to visualize. We will begin by considering the first element of the array already sorted. We will move to the next element of the array and assign a variable next index equal to 1. Whatever the value is in the next index, we will assign to a variable named insert value. Notice insert value is equal to the element in next index. Next, we will create a variable called compare index and assign it to the value which is 1 less than next index. Now we will ask 2 questions. Is the compare index greater than or equal to 0? In this case, the compare index is equal to 0, so the answer to the question is yes. Our second question is the insert value less than the value in compare index. The insert value is equal to 44, and the value in compare index is equal to 99. So yes, 44 is less than 99. We have a yes for both of the questions. In this case, what we will do is copy the value which is in compare index to the value to the right, compare index plus 1. Next, we will subtract 1 from the compare index. The compare index will be -1. Now we will ask our 2 questions again. Is the compare index greater than or equal to 0? For this question, the answer is no. -1 is not greater than 0. We do not need to ask our second question. We can take the value which is in insert value and assign it to the value of compare index plus 1. Insert value will fill the first slot of the array. We now have 2 sorted elements in the array, and we have completed our first pass. Next, we will increment next index by 1. We will assign the value stored in next index, which is 26, to the insert value. We will set compare index equal to next index minus 1. We will ask our 2 questions. Is compare index greater than or equal to 0? Compare index is equal to 1, so yes, compare index is greater than or equal to 0. Is insert value less than the value in compare index? Insert value is 26, and the value in compare index is 99. 26 is less than 99. Since both of these questions are true, we will copy the value that is in compare index to the location of compare index plus 1. Next, we will subtract 1 from compare index. Compare index is now 0. We will repeat our 2 questions. Is compare index greater than or equal to 0? The answer is yes, compare index is equal to 0. So compare index is greater than or equal to 0. Is insert value less than the value in compare index? Remember that insert value is equal to 26, and the value in compare index is now 44. Since 26 is less than 44, the answer to this is also yes. We will copy the value from compare index into compare index plus 1. Next, we will subtract 1 from compare index. Compare index is now -1. We will ask our 2 questions. Is compare index greater than or equal to 0? The answer is no, so we can stop the comparisons and place insert value in the location of compare index plus 1. We are now finished the second pass. Next, we will increase the value of next index by 1. Next index is equal to 3. We will assign insert value the value stored in next index. Insert value is equal to 69. We will assign compare index a value which is next index minus 1. Next index is equal to 3, so compare index will be equal to 2. We will now ask our two questions. Is compare index greater than or equal to 0? Compare index is equal to 2, so yes, it is greater than 0. Is insert value less than the value in compare index? Remember, insert value is equal to 69, and the value in compare index is equal to 99. So insert value is less than the value stored in the compare index. Since both of these statements are true, we will copy the value that is in compare index to compare index plus 1. Next, we will decrease the value of compare index by 1. Compare index is equal to 1. We will repeat our two questions. Is compare index greater than or equal to 0? Here, compare index is equal to 1, and it is greater than 0. So the answer to this question is yes. Is insert value less than the value in compare index? Insert value is currently 69. The value in compare index is 44. Is 69 less than 44? The answer is no. We will stop the process at this point and assign insert value to the value at compare index plus 1. We have now completed the third pass. Now we will increase the value of next index by 1. Next index is equal to 4. Insert value will be assigned the element stored in next index, so insert value is now equal to 37. We will assign compare index the value of next index minus 1. Then we will ask our two questions. Is compare index greater than or equal to 0? Here, compare index is equal to 3, and 3 is greater than 0, so the answer is yes. Is insert value less than the value in compare index? Insert value is currently 37, and the value in compare index is 99. Since 37 is less than 99, the answer to this question is true. Since this is the case, we will copy the value in compare index to the value in compare index plus 1. We will decrease the value of compare index by 1. Now we will ask our two questions again. Is compare index greater than or equal to 0? Here, compare index is equal to 2, and 2 is greater than 0, so the answer is yes. The second question, is insert value less than the value in compare index, is also true. If we look at insert value, this is the value 37. We want to know, is 37 less than 69? Again, this is true, so we will copy the value of compare index into the value of compare index plus 1. We will decrease the value of compare index by 1, and we will repeat the two questions. Is compare index less than or equal to 0? Compare index is equal to 1, and yes, 1 is greater than or equal to 0. So the answer to the first question is yes. Is insert value less than the value in compare index? Currently, insert value is equal to 37. The value in compare index is equal to 44. We will decrease the value of compare index by 1, and we will repeat our two questions. Is compare index greater than or equal to 0? Compare index is equal to 0, so the answer to this question is yes. Is insert value less than the value in compare index? Insert value is currently 37. We want to know if this is less than the value in compare index, which is 26. 37 is not less than 26, so we will insert the value in insert value into the value of compare index plus 1. This completes the fourth pass, and our array is in sorted ascending order. Now we will take a look at the insertion sort algorithm. For each unsorted element in the array, from the second to last element, we will store the element, set the compare index to 1 less than the index of the element, and we will loop while the compare index is greater than or equal to 0 and the insert value is less than the compare value. For each pass of the loop, we will copy the compare value into the element to the right and subtract 1 from the compare index. When we pop out of the loop, we will insert the element into the location of the compare index plus 1.
You'll notice that I've opened the Insertion Sort demo file in NetBeans. In the code window, on line 1, we declare the package Insertion Sort Demo. You can see that this is the package declared in the Projects folder. On line 6, we declare the class, and on line 7, we declare the main method. Line 9 does nothing more than declare an array of the int primitive type. Notice we're creating this array with 5 elements, and these elements match the 5 elements that we saw in our example. On line 10, we declare a final called int array length, which stores the length of our array. On line 12, we will print the string unsorted arrays, followed by a line return. Line 13 calls the method called printArray. First argument is the pass. Each time we go through the for loop of the insertion sort, we call it a pass, and this will allow us to track the pass number. Because this is the unsorted array, we're using the pass value of 0. Next, we will pass in the array of integers that we declared on line 9. And lastly, we will pass in the final that we declared on line 10. Looking at printArray, we see the parameters pass, the array, and the array length. Notice that this method will print the pass number, and a for loop will print each of the elements in the array. After all of the elements have printed, we will print a line return. On line 14, we will print 2 line returns, and on line 16, we will begin processing the insertion sort. Notice that the for loop in the insertion sort does not begin with index 0, it begins with the second element in the array, which is index 1. We will move from this index to the last index in the array. Just as we saw in our example, the first thing that we will do is we will declare insert value and assign it the value stored in the array at next index. We will declare a variable called compare index and set compare index equal to next index minus 1. Within the for loop, we will have a while loop. This while loop will be responsible for finding the location to place the insert value. Notice our 2 conditions appear within the while loop. While compare index is greater than or equal to 0, and the insert value is less than the value stored at compare index. Line 21, copy the value of compare index into the value of compare index plus 1. And line 22 decreases the value of compare index by 1. After we found the place to insert the insert value, we will perform the insertion at line 25. Line 26 will perform the print array again using next index. Notice that next index is equal to 1. Each time we increment next index in our for loop, the pass value will increment as well. To quickly recap, this is the for loop, which moves from the second element to the last element in the array, and this is the while loop, which looks for the location in which to place our insert value. This concludes our discussion of the insertion sort. I hope you found this information useful.